Well, welcome back to another lesson in our series. Tonight, we're going to solve radical equations, but here's the catch. What happens when you cannot isolate the radical? So let's get our feet wet with this first example. 3x equals 1 plus 2 radical x. So remember, step number 1 in radical equations is to isolate the radical, or get it by itself. So hopefully you would agree the first thing we're going to do is subtract the 1 over. So that would leave me with 3x minus 1 equals 2 radical x. All right, is that radical isolated yet? I would say no, there's still a 2 in front. So what am I going to do? I'm going to divide both sides by 2. So here I get 3x minus 1 over 2 equals radical x. All right, once the radical is isolated, I'm going to wrap each side up and square it. So the right side is real nice. Anytime I square a square root, they just cancel, and I'll get x here. Now this side's a little uglier. I'm going to write it down twice, of course, and multiply it by itself. So the top part I'm going to have to FOIL out. So what is that? 9x squared minus 3x plus 1. And the bottom I'm going to multiply, and that's just going to get me a 4 equals x. Again, I'm going to keep cleaning up, so that's 9x squared minus 6x plus 1 all over 4 equals x. At this point, hopefully you're saying I've got a fraction equal to, I can make this a fraction by putting it over 1, and I'm going to cross multiply. So this piece, 9x squared minus 6x plus 1 equals this piece, 4x. Of course, then we'll set her equal to 0. 9x squared, I'm going to subtract the 4x over, so minus 10x plus 1 equals 0. We've got some nice factoring going on here. Now, we have a little guess and check. So my options for the first one are either 9 and 1 or 3 and 3. My options for the last are 1 and 1, so that's easy. And this plus is telling me the signs are the same, and this minus is telling me that they're both negative. All right, so now I just have to figure out how I'm going to get a 10. Would I want a 9 and a 1 or a 3 and a 3? I think I'm going to go with 9 and 1 and see what happens. Remember to check the outsides and check the insides. So that's going to get me a negative 9x, that's going to get me a negative 1x, and that'll get me a negative 10x. So I know I factored correctly. So now I'm just going to tee up each piece, each of my factors, and we'll write it out. 9x minus 1 equals 0, and x minus 1 equals 0. And of course, just solve. So 9x equals 1, x equals 1/9, and x equals 1. Now comes the fun part. Don't forget you have to check for those extraneous roots, numbers that do not work. So let me rewrite that original question down. 3x equals 1 plus 2 radical x. And I'm going to start with the easy one. I'm going to substitute in a 1. 3 times 1 equals 1 plus 2 times the square root of 1. So that's 3 equals 1 plus the square root of 1 is 1 times 2 is 2. 3 equals 3. We love that answer. That works. And now we'll check with our 1/9. So 3x equals 1 plus 2 radical x. Plug in that 1/9. 3 times 1/9 equals 1 plus 2 times the square root of 1/9. Now maybe that makes you nervous, but it's actually a really nice number, the square root of 1/9. Think about this. Do you know the square root of 1? Sure, that's 1. And do you know the square root of 9? Of course, that's just 3. So the square root of 1/9 is just 1/3. And then here, when I multiply, I'm going to get 3 over 9. Now, if you need to use your calculator, that's fine too. 3/9 reduces to 1/3. And here I'm going to get 1 plus 2/3. 1 I'm really going to call 3/3. So I get 1/3 equals 5/3. I would say those are not equal. Therefore, I'm going to reject the 1/9 answer, and I'm going to say my only solution is x equals 1. All right, now that we're warmed up and ready to go, let's take a look at this rascal. radical x plus 3 equals 3. So remember, my goal is to isolate the radical. Is it possible to get the radical by itself if you have two radicals? Well, if there wasn't a 3 here, you could move 1 over to the other side, and then each radical would be alone. But there is a 3 there. So what happens? Well, all we're going to have to do is just separate the radicals. So let's make a note. Separate radicals. I'm going to abbreviate there on each side. Okay, so separate the radicals on each side. So what am I going to do? I'm going to move one radical to the other side. Now it doesn't matter which one you move. I'm going to leave the radical x plus 3, and I'm going to subtract the radical x to each side. Okay, and again, it didn't matter which one I moved. So that equals 3 minus radical x. Now we're going to do the same thing, but we just have to be very careful. I'm going to wrap each side up and square it. Okay, now this side is particularly very easy because this square and square root are just going to cancel and you're just left with x plus 3. However, this side is not as nice. These don't cancel anymore because you have a binomial. You have two terms. So you basically have to write that out twice and FOIL. So 3 minus radical x times 3 minus radical x. So I'll keep cleaning up here. X plus 3 equals, we'll FOIL. So 3 times 3 is 9, minus 3 radical x, then a minus 3 radical x, then a negative times a negative is a positive, and radical x times radical x, hopefully you've got now, you could say radical x squared, but we should know it's just x. Now notice, these are not conjugates, they should not cancel. So I get x plus 3 equals 9 minus 6 radical x plus x. All right, I'm going to keep solving. But do you notice this? Do you notice we started with a radical equation and we're getting a second equation with a radical in it? We basically have to solve two radical equations. So now my goal is to isolate this radical. So I'm going to subtract the 9 over. So I get x minus 6 equals negative 6 radical x plus x. I'm going to subtract this x over. So I get negative 6 equals negative 6 radical x. I want to isolate that radical, so I'm going to divide both sides by negative 6. So those divide to a positive 1 equals radical x. Wrap each side up to isolate that radical and get rid of it, square it, and I should get x equals 1. Now remember, that doesn't mean that's my final answer. I do need to check. So I'm going to go back and check x equals 1. I have to rewrite my original equation down here. So I'm going to check up here actually. So radical 1 plus radical 1 plus 3 equals 3. Well, the square root of 1 is 1. That's really 4, and the square root of 4 is 2. And I would say 3 equals 3. So I know my solution 1 does check. All right, we're ready to tackle the second one. Again, I've got two radicals, so you can't isolate the radical. All you can do is move one of them to the other side. So again, pick your favorite. It doesn't really matter. I'm going to leave the x minus 3, and I'm going to boot over the other radical. All right, it gets the boot here. All right, then I'm going to eliminate this radical by wrapping it up and squaring, and then I'll do the same to this side. Remember how nice that square and square root are, so here I just get x minus 3. And on this side, unfortunately, I just have to write twice and carefully FOIL. All right, now comes the fun part. Just take your time and keep things neat. X minus 3 equals, as I FOIL, so that's going to be 4 times 4, is 16. And then it's going to be minus 4 radical x plus 5. Minus 4 radical x plus 5. Shoot, I'm going to go off the page here. A negative times a negative is going to be plus. And remember, any radical times itself is just that stuff inside. So plus x plus 5. Okay, so I'm going to carefully clean this up. X minus 3 equals, I can put my 16 and 5 together, so that's 21 plus x minus 8 radical x plus 5. So that goal is to isolate that radical. I want to get that radical by itself. So I'm going to move things over again. I'm going to subtract 21, and I'm going to subtract the x at the same time. So look how nice those cancel, and that's just negative 24 equals a negative 8 radical x plus 5. Now we're not at the point where I want to square both sides yet. I'm going to divide both sides by negative 8 because I want to isolate the radical. And I get 3 equals the square root of x plus 5. So that radical's isolated. We'll wrap it up and square it. Wrap it up and square it. So 9 equals x plus 5. Subtract the 5, and x equals 4. Again, I'm not done until I go back and check for any extraneous roots. So I'm just going to carefully plug that 4 back in. So 4 minus 3 plus 4 plus 5 has to equal 4. Let's give it a whirl. 4 minus 3 is 1. The square root of 1 is 1. 4 plus 5 is 9. The square root of 9 is 3. And I would say 4 equals 4, which checks. So my solution is 4. All right, let's give this one a whirl. Now, what's nice is they basically already have the radical separated for you. Beautiful. So we're just going to wrap it up and square both sides. All right, why don't you pause it? You work out your line, and then we'll compare. So don't cheat yourself here. This is where the important part comes in. Pause it and see what you get. So you can see what I did. I wrote it out twice. I killed that side with the radical, and then I put my like terms together. So I'm going to subtract over the x, which is going to get rid of that x. I'm going to subtract my 9, so I'm going to get 6 radical x equals 72. Divide both sides by 6 to isolate that radical. So I get radical x, let's see, 72, that gets me 12. Square both sides, and I get 144. Now at this point, hopefully you're feeling pretty good. Obviously you want to go back and check. If your answer gets rejected, remember we call that an extraneous root, and that's okay. Sometimes we have no solution. All right, in this next example, 2 cubed root of 3x plus 2 equals the cubed root of 4x minus 9. Now, this one's slightly different, because take a look at this. The radicals, or roots, are already on opposite sides, but it's not possible to isolate this one, right? Notice this 2 is attached to it, but not with a plus sign, so you have to be real careful. So in order to get rid of a cubed root, you know it, we're going to cube both sides. But like I said, we have to be real careful. Watch how I wrap this side and this side. All right, so the easy side, the cubed and the cubed root disappear, and I get my 4x minus 9. On this side, remember, I'm going to actually write it out how many times when I cube something. Remember, that's just repeated multiplication, and I actually have 3 of them. Okay, and that cubed root's important. Make sure we don't lose that. So now take a look at this number out front. Notice I'm not foiling this time because there's not binomials. It's not a plus or minus. It's 2 times 2 times 2, which is 8. And the cubed root times itself 3 times. Again, I can think of those just canceling. So that's going to be my 3x plus 2. Okay, so the whole point I wanted to show you is that you're not foiling because there's no plus sign here. Because this was multiplication, you had to cube the 2, which became the 8. And when you cubed our cubed root, you just get what's under it. So that's equal to my 4x minus 9. So I've got 24x plus 16 equals 4x minus 9. Subtract that 4x over. 20x, subtract that 16 over, equals negative 25. Divide by my 20. And I get x equals negative 25 over 20. Let's see, 5 goes into both of those, so negative 5 over 4. Now remember, that doesn't mean that's the answer. I could have no solution. I have to make sure I check for that extraneous root by plugging it back into the original. Another key you could use, we talked about this earlier in the year. Let's practice it now. Grab that calculator and type in negative 5/4, hit the stow button or store, Okay, it says stow on your calculator, store. And we'll hit store into x. Then you just hit enter. This is a quicker way to check, which I think is much smarter. -5/4 store into x and hit enter. And then we'll just go back and we'll type this original equation in. And we just want to see if this side, when you type it in and hit enter, is equal to this side. Cube roots, don't forget, can be found under the math feature. If you hit that button on your calculator, arrow down, you'll see a cubed root. And again, we just want to check and make sure they're equivalent. All right, well that does it for us on our last day of radical equations. Good luck, and we look forward to your questions tomorrow.